Hey guys, on today's video I'm going to be building a mounting plate for a 4-inch 3-jaw chuck. I have a couple of slots so that I can mount this to the mill because I need to do some machining on the pulleys, and what better way to hold a round object than a 3-jaw chuck. Let's take a look at Fusion 360 and we'll see what I came up with. Okay, so here is the 4-inch 3-jaw chuck mount. Very simple design. I just really needed something that would allow me to mount the chuck to the mill so that I could hold round stock more easily. So basically what we have here is a 1/2 inch thick 4-inch by 7-inch piece of aluminum that we've just bored some holes and milled some slots in. The distance between the top of the stock and this recess here is 100 thousandths, 0.10. Then on the back side we have a recess for the cap screws. I've got mine 1/4 inch deep, and the diameter is 16 millimeters, 0.63. So let's take a look at the cam operations. Notice that Fusion 360 is just updated and we now have the sheet metal available to us. So first operation is to drill our holes, one clearance hole here for the center and then our 3 mounting holes. I'm then going to come back with a 2-flute 3/8 inch end mill. I'm going to do my center hole here with just a boring operation. I think this is 25 inches per minute at 3,000 RPMs with a 40 thousandths spiral depth of cut here. 0.0393701, almost 40 thousandths. Next we're going to do some adaptive clearing, again using a 2-flute 3/8 inch end mill. This is 30 inches per minute, 3,000 RPMs, and a 60 thousandths width of cut. We're also going to come back and we're going to mill these slots out at the same time. There we go. We're milling the slots out. And then last, we're going to come back with a 4-flute 3/8 inch end mill, and I'm going to just clean all this surface up here. Now, I went with the same width of cut, but I should have probably went with more like 300 thousandths width of cut to speed this up, because there was really nothing there to machine except for about 1/1000th of an inch. So just something you learn when you're machining. You don't always get it right the first time, and so there's always tweaks and changes you want to make, but we pushed on through and got it done. And then the last operation, we're going to just flip the stock over, and I'm going to do, this is a different setup, I'm going to be doing the recess for the cap screws. And I've used the impact tolerant touch probe to find the center of the stock and the center of this hole to reference this operation. So that's basically it for the 4-inch 3-jaw chuck. So now let's go out to the mill and we'll machine this out. One thing I wanted to point out, this is a new chuck, and whenever you get a new chuck, or any chuck for that matter, you're usually get 2 sets of jaws, and they're all numbered 1, 2, and 3. I don't know if you can see that. And it's good to also take a punch. You can pick up a set of these stamping alphabets. This is Harbor Freight. It was just a few bucks. And stamp the corresponding number to the side of the chuck, and then that way you can get all the gear, all the jaws back in the correct position. And then this one is 2. Alright, going to be using a piece of 1/2-inch thick 4-inch by 7-inch stock. You can use, this is just something I had. You could use rounds, you could use a rectangle piece. I've already got this. This is 4 inches wide already. I'm just going to clean up the edges. Doesn't have to be perfect. And then we'll do the machining. Alright, so let's take it to the Precision Matthews and we'll get this milled out. Alright, so I took the fly cutter. This is a Tormach Superfly. Works really well. And surface the bottom. This will be the bottom that will sit on top of my table. But I wanted to get it first. So now I'm just going to indicate this corner here. We're going to make sure we have our probing tool set up, 99. And I'm going to be using button 3. And it's that simple. Now I've got my X, Y, and Z 0 set on this particular corner, and now we can start doing some machining. Alright, here we go. We're going to do 3 recess holes. I've got a 1/4 inch 2 flute end mill, and we're running at 3,000 RPMs. Make sure I turn the spindle back on. Here we go. Made short work of that. Alright, made short work of that. I'm using a 1/4 inch 2-flute end mill. This is actually an old used end mill that I had a gentleman send me. He is a CNC machinist, and they were out of tolerance for the work he was doing, so he sent me some different end mills to try. I appreciate that. Eric, thanks for the turning me on to the 2-flute end mill and 3-flute for finishing aluminum, and also for sending me some to try out. I knew that I needed to use 3-flute and 2-flute end mills for aluminum. I just never did practice it. Alright, so let's get this flipped over and we'll start machining at the top. Okay, I flipped the stock over here, and now we're going to indicate the top left corner. Because I flipped it, I want to keep the same corner as my reference. So again, I want to go to my offsets page. I want to type in tool number 99. I want to make sure my spindle is turned off, and I want to reference this top corner here. Okay, here we go. Alright, we've got the corner referenced, and now we can start running our code. that was at 30 inches per minute. This groove right here, this slot, I probably could have slowed that down a little bit. And some serious, it was taking some really serious chips. Another thing is, one mistake I did make, because I'm going to be taking the vise off when I finish this, I didn't put in my air hose to cover up these grooves, and I didn't put in my pockets, and you could see it all filling up with coolant, and now I've got to get all these chips out. So it's the first time I've ever really ran the mill without that in there, and what a mess. These drain holes, they fill up with chips, and then the coolant doesn't want to drain, so not very good. Also, while I'm speaking of these pockets, a buddy of mine, Wyatt, machined me out some of these awesome looking aluminum pocket covers. They're so nice, I didn't want to stick them in there because, well, they're just going to get tarnished from the coolant. But they are sweet. They're almost like a desk piece. Wyatt, really appreciate that. These are awesome. Okay, so pretty much done here. This could probably go back and do a finishing pass, and I might come back and hit this with the fly, the super fly, just to make sure that that's flat, but it shouldn't bottom out, but we'll check it before I do that. Alright, although you can see these little marks here, it's really pretty smooth. I think this right here I'll just leave. It doesn't really need to be surfaced because it doesn't stick up high enough. Nothing's actually resting on that. But overall, turned out really nice. And it should be just the trick for what we need to mount the 3-jaw chuck. Alright, so let's get this out and we'll see if the chuck fits on there. Alright, well, it turned out pretty good. Now we just need to get it assembled. You can see you have the recess here, and we'll just mount it up. Well, turned out pretty good. Now we can just bolt this down on the mill And now if we have any round stock we need to machine, like for instance my pulleys, then you can easily hold it. Now I don't want to mess the pulleys up, so I've cut these little aluminum shims here, and that'll just keep the jaws from getting marring the work here. And that should keep our round stock nice and secure, and we can machine for the 3 pins. So in the next video we'll do some machining on this pulley and continue with the belt drive. If you're interested in a 3-jaw chuck mount, this particular one is for a 4-inch. However, you could easily modify the models. I'll post those models or link to those models in the video. If you have any suggestions or questions, please feel free to comment. Thanks for watching. Please subscribe to the YouTube channel. Thumbs up if you like the video, and most importantly, be safe.